Morning, everybody, or afternoon. You know how it is. Um, we're almost done. We're on the last section of geometry, 3D geometry. Now, uh, it's gonna be a long video, so I'm gonna try and speed through it a little bit, uh, but still, get through everything that we need to talk about. But it's gonna be a long video. Sorry about that, guys. Hopefully, we can speed through it. All right. Well, the first thing we're going to talk about is volume. Volume is filling up a 3D shape. So I'd like you to imagine if you were doing surface area, right, you would have, where's my little drawing thing? It's like, let's say we had this guy. If you're doing surface area, you'd be like, all right, how many of these squares fit inside this shape, right? Not the best example, they should be perfectly the same size, but yeah, like how many squares would it take to fill this up? That would be surface area. Volume is like how many cubes would it take to fill up a physical space? So like in your bedroom or your living room, wherever you are, imagine, I don't know, Amazon boxes, right? Or cardboard boxes. How many of the exact same size boxes would it take to fill up the space you're in? That's volume. And there's formulas for volume. We'll do, there we go. I drew all these 3D shapes and I'm proud of them. So yeah, whatever. All right. So the very first one we're going to talk about are prisms. Prisms. A prism is a 3D shape, right? 3D shape. Let me step this. There we go. 3D shape with at least two sides the same shape and parallel. So what that means is looking at this cube. It's not a cube, actually. It's a rectangular prism because this isn't a cube. It's not the same sides, right? If it was 5 and 5 or 6 and 6, it would be a cube. But it's not. It's a rectangular prism. If you look down here, this little square is 5 by 6. And across the shape at the top here is 5 by 6 as well. So it's two of the same shape that are parallel to each other. That makes it a prism. And volume of a prism is a simple formula. It is big B times big H. That's it. Now, the problem is that a lot of people think, sorry, my phone went off. B means base, H means height. But if you notice, these are capitalized. And they're capitalized for a very, very good reason. Because, do a little carrot, do I have to draw it? Whatever. We'll be fine. So B, capital B equals area of the base. Capital H equals height of the prism. So they're two very, very different things. And unfortunately, a lot of students mix these up and they're like, oh, base times height, 5 times 6. Well, then, don't do that. It's area of the base times the height of the prism. So in this case, our base is a rectangle, right? Our base is a rectangle. So area of the base times height of the prism would give us base times height times height of the prism. Since the base is a rectangle, and area of the rectangle is base times height. So that's how you need to look at this formula. You're given this formula on the exam, but you're literally given it. Well, first off, you're given volume. It just says volume. It doesn't even tell you volume of what. Like volume of a sphere, volume of a cone, pyramid. It doesn't say anything. It just says volume equals B times H. Well, that's not very helpful if you don't know exactly what I just said. Area of the base, height of the prism, right? But coming back over here, we need area of the base, which is base times height of the base times the height of the prism. So all we have to do is look at the bottom here, find its area, multiply that by 6, and you're done. So we plug that in. The base of the base is 5 times, well, the height of our base is 6, and the height of the prism is 6. Here's the nice thing, since it's all multiplication, the order doesn't matter. You can do it in whatever order you want. There we go. No. So 5 times 6 equals times 6, and you're done. The volume of this prism is 180 feet cubed. Remember how I said boxes, like cubes filling up the space? Well, it's the unit of measure cubed. All right, not bad, right? I mean, if you know the formula, it's nice and easy. That's this entire chapter. If you know the formula, it's really, really easy. I'm going to try and keep the formulas down to a minimum, especially when we get to surface area, because you got enough formulas to remember. So we're going to try and get rid of as many formulas as we can while still having you be able to do it. But right, rectangular prisms are really easy. Area of the base times the height of the prism. But I did just say rectangular prisms are easy, right? Well, not all prisms are rectangular. So we have this situation, right? So this is also a prism because you've got a right triangle here facing us, but in the back, you've got a right triangle. They're the exact same right triangle, so they're parallel and the same shape. So this is a prism. Also, if you didn't discern this already, dotted lines are lines behind the shape. So like we're looking at this from a specific point of view. And the dotted lines are the lines that we can't see. That makes sense? I hope it makes sense. So yeah, the dotted lines are like behind the shape. Okay, so the nice thing is that anything that's a prism, regardless of what it looks like, has the exact same volume formula. Area of the base times height. Now the base on this one is not this rectangle down here. Because if you go straight across from this rectangle, you don't find another one. Same with this. This rectangle right here, there's nothing across from it. Same with the slant. So the only base is this right triangle. Because if you go straight across, if you follow the lines straight across from this right triangle, you run into another right triangle that is the same shape and parallel to it. So your base is this right triangle. Your base is not always what's on the ground. I hope that makes sense. Your base is always the shape that has a parallel side across from it. It'll always be straight across. You can follow the lines straight across and they should be connected. All right. Well, regardless, the volume formula for this is still area of the base times height of the prism. But our base is a triangle. And triangles are 1/2. Area of a triangle is 1/2 base times height. Height. I'm all over the place. And then we still got our times height of the prism. Well, now we just plug in numbers. Our 1/2 doesn't change. And then since this is a right triangle, we already know its height, don't we? Because we've got this line going from the very top straight down to the bottom, making a right angle. That's the height. So we have the height and we have the base. We can just plug in 1/2 of 13. Ooh, that looks crazy. 1/2 of, I'll put a times there because it looks bad. And a space because it looks really bad. 13 times 1/2, 13 times 10. Times, and then we need the height of the prism. Now, the height of the prism is not always the line you see going straight down, right? The prism. The height of the prism is essentially the distance between your two parallel bases. So I've got this right triangle here. I've got the right triangle in the back, and they are 6 millimeters apart from each other. So that is the height of my prism. So whatever the base is, you would imagine laying it down on that side, and then that would be your base, and then going up would be your height. But don't let them trick you when they lay something down, like on its side, like they did here. But once we're there, we're done. Just plug this in, right? So 1/2, 1 divided by 2 equals 0.5 times 13 times 10. And then we did all that in here, so then we go to the outside, times 6. And we're done. Volume equals 390 millimeters cubed. So I have 13 examples. We have done 2 of them. But I really, really want to make sure that you guys understand what I'm talking about and like what I'm implying and how I'm going through this. So I'm going to kind of speed up a little bit here. And I mean, if you miss anything, you know, you can rewind, pause, slow the video down, whatever you have to do. But I mean, I don't want this to be like an hour and a half long. And I want to talk about everything. All right, so looking at this guy, this is officially called a cylinder. It's officially called a cylinder. And if you look it up, you'll find that cylinders have their own volume formula. But we're not going to use that because a cylinder is a prism and it has the same volume formula. It's still area of the base times height. But in a cylinder, the base is always a circle. But it doesn't matter because it's still a prism. So all we need to do is area of a circle, right? Which is, oh, that's right, I hate that. That's a pi symbol. I'll leave it as is. It's fine. Is it? It's fine. Pi. God, it's an ugly pi. Why am I such a perfectionist? Oh my goodness. Don't live your life like me. It's harder. Let's do this. Edit. Shrink down. Bring that over here. Okay. Right? Area of the base times height. And we know that area of a circle is pi times r squared. Oops. Pi times r squared times, well, height of the prism. In this case, height of the cylinder. So we're done. We already have our 2 numbers, right? We got our radius, we got our height of the prism. We just plug them in. We got pi times 22 squared times 124. So bring over here to our calculator, and finish it up. Pi times 22 squared equals times 124. And that's a big number, but that is the volume. Man, I cannot spell volume today, apparently. All right, volume equals 188,545.82 centimeters cubed. Well, don't let them changing the shape of the prism confuse you. All right, just if it's a prism, then just follow those instructions. All right. So moving on to the next one. We're finally not talking about prisms. We're going to talk about a pyramid. So pyramids, oh, I need annotate, select. No, there we go. So this is a pyramid, right? Which I guess the best definition of a pyramid would be a 3D 3D shape where a base's points are equal distance from a single point above. Well, I guess above is unnecessary. A single point. What I mean is, you've got this rectangle down here, right? You got this rectangle, and then you've got these lines going up to a single point. And all four of these lines, right, from the edges of our rectangle are all the same distance going to the same point. It has its own volume formula, of course, right? 1 divided by 3, or 1/3, times area of the base times height of the pyramid. Nice and easy. And then, of course, B equals area of the base. Big H equals height of pyramid. And from there, we can just solve this out. Because it's incredibly similar to what we've been doing, isn't it? You just have to do the 1/3, which is the same as dividing by 3. So multiplying by 1/3 is the same as dividing by 3. So this could be area of the base times height of the pyramid over 3. They're going to write it like this on your test, which is why I show it to you like that. So we got 1 divided by 3 times area of the base times height of the pyramid, which is 1 divided by 3 times, well, the base is a rectangle, right? So it's base times height times the height of the pyramid. Well, we can plug all our numbers in. 1 divided by 3 times, come to your base here, 15 and 12 are your sides. It doesn't matter which one you use. So we'll just go in order. 15 times 12 times, and then the height of the pyramid is displayed out here, right? So this is our height. It goes from the tip straight to the base, like the very point to the base. So we're going to use that as our height of our pyramid. So now we just plug that into our calculator. Clear this out. I'm going to do the parentheses first. Then I'm going to do the 22, and then I'm going to deal with this guy. Well, actually, I don't have to. It's all multiplication, right? I could do 1 divided by 3 equals, right? Times 15 times 12 times 22 equals, and that's it. Volume equals 1,320 inches cubed. Oops, a daisy. Inches cubed. So I don't think volume is difficult. I just wanted to show you volume and all these different shapes real quick because, yeah, I didn't want you getting confused when you saw the quiz. So let's go ahead and move on and move forward. Close this out. Move on to the next thing, which is this guy. Oh, I'm going to edit him. One. Edit him, move on, here we go. So now we've got a cone. A cone is no different. A cone is the exact same formula as a pyramid. It's still going to be 1 divided by 3 times area of the base times height of the cone. The same formula, so we're not going to change anything. The only difference is 1 divided by 3 times the area of the base. Well, the base's shape is a circle, so it's circle, or area of a circle, which is pi r squared times the height of the cone. And that's it. We plug in our numbers. 1 over 3 times, ooh, what was that? Times pi, and then let's go. Our radius is 13. Whoa. There we go. Radius is 13, and the height of our cone is 96. From there, we can just run it through. 1 divided by 3 equals times pi times 13 squared times 96 equals a big number. All right. So we got 16,989.73 feet. Nope, not squared, cubed. There we go. So same formula, easy peasy lemon squeezy, right? So let's move on to our last volume formula, which is a sphere. So spheres look intimidating. Sphere is a 3D shape where all points from the center are equal, or where all points are equal distance from the center. What that essentially states is that a sphere has a radius, and the radius are equal, just like any circle. So if I go from the center of the circle, right, I go from the center of the circle here to the outside, that's 29 yards. If I go from this center out here to any part of this circle, it's 29 yards. That's the radius. But if I go from here to the edge of the sphere, it's still 29 yards. It's going to be 29 yards from the center of the circle to any point on the circle. On the sphere. Any point from the center to the edge is going to be 29 yards. It's going to all be the same radius. But, I need to edit. Hold on. Anytime we do, there we go, circles, I'm going to have to edit. Okay. So, formula. Oh, I got to do it there too. Dang it. What is... Okay, that's a little pi symbol. It's really tiny, man. Change its size? There we go. Okay. So, a sphere's volume formula is 4 over 3, 4/3, times pi r cubed. Pi r cubed. So if you've been paying attention, or you know your formulas fairly well, you're going to start noticing that a lot of the volume formulas are very close to the area formulas with like some tweaks, some little changes here and there. Like the pi r cubed, well, area of a circle is pi r squared. So this is kind of close. I mean, without the addition of the 4/3, 4 over 3. But yeah, a lot of things look similar. But here's a really nice thing about spheres. You notice as you go through this whole equation, there's only one variable. If you know the radius of the sphere, you can find its volume, you can find its surface area, you can find everything. You only need one number. And we have that number because it's right there. So 4 over 3 times pi r cubed. Well, the only number there is r, so 4 over 3 times pi, and then 29 cubed. We'll just plug that into our calculator and be done with this question. 4 divided by 3 equals... So remember, the reason why I hit equals is because there's a division sign. You can do all your multiplication in any order you want, but you got to get rid of this division first. So that's why I do that first. 4 divided by 3 equals, then I can do times pi times 29. This is squared, but if I hit the second symbol, it'll become cubed. And then hit equals. which means volume, man, volume, the word volume is not friendly today. Volume, 102,160.4, that's it, 40. And then this 4 doesn't round up, so it's 40 or just 4 yards cubed. Easy peasy. I hope it is. I really do hope it is for you. All right. So close this. Move on to the next example, which is our last volume example, which I need to edit. But it's got a sphere in it. There we go. All right. So sometimes you'll be asked to find the volume or surface area of a shape that is not normal. It's not just a, here's a cylinder, here's a prism, here's a cone. You know, it's weird. It's complex. In this case, they call them compound, where it is two shapes put together, which means all you're going to do is chop them up so they make sense. And then you're just going to do this. You're going to do volume for two shapes and then add those volumes together. So we do have two shapes here, don't we? We have, I'll do it with a red line. So we've got the cylinder here, right? And on top of it, we've got this, what looks like a sphere, but it's only half of it. That's literally what it is. It's a semi-sphere. Write that out. I'll write it in here. So a semi-sphere is half a sphere. It's not complicated in any way. Any formula you get for spheres, you know, volume formula of a sphere, get the volume of it and then divide it by 2. And then that's it. Like, you got it. Oh, I need to add a height. Otherwise, we can't do this. There we go. But yeah, a semisphere is half a sphere. So if you did volume of a sphere, if it was a semisphere, you would do volume of a sphere divided by 2 at the end. And then you've got your volume of the semisphere. Okay. So we got a semisphere on top and then a prism on bottom. So all we're going to do is those two formulas separate, and then we're going to add them together. Now, this prism has a circle as its base. So we know that, let me get rid of this guy. No. Let me get rid of this guy, and that guy, and I gotta redo my 15. Okay, so let's figure this out. I'm gonna do the cylinder first. I'm gonna do the prism first. So our prism is area of the base times height. Our base happens to be a circle, which means pi times r squared times the height of the prism. And we have all this information, right? We have our radius, because again, this circle up here and this circle up here are our bases for our prism. Remember, we're cutting off this sphere, this dome, cutting it off and just looking at the prism. Because we have a volume formula for the prism, we don't have a volume formula for a prism with a semisphere on top. We'll fix that. So let's just plug in and find the volume of our prism. So we got our radius and we got our height. Our radius is 8 squared times our height, which is 15. So we're going to plug that into our calculator over here, figure it all out. We got pi times 8 squared equals times 15. So volume of prism, right? Volume of this prism equals, we got 3,015.93. That's going to be miles cubed. The volume of our prism down here. We haven't touched the top though. So let's do the top. Let's figure that out. The semisphere. So we're going to do everything we did for a sphere, and then at the very end, we're going to divide it by 2. There's no reason to complicate it, right? So we've got 4 by 3 times pi r cubed over 2. Since this is a semisphere, we're going to divide it by 2 at the end. Nice thing is, the only variable is radius, and we have it. So we just got to plug that in. 4 over 3 times pi, and then our radius is 8 cubed over 2. There we go. So we're going to plug that in. I'm going to save the divided by 2 for the very end because it just complicates things otherwise. So let's do 4 divided by 3 equals times pi times 8 second cubed equals. So that would be the volume of a sphere with a radius of 8. But now we need to divide that by 2 at the very end because this is only half of that. So now we've got volume of semisphere. Wow, this is getting really, really jam-packed. Equals, oh, this is ugly. I hate it, but it's fine. All right, volume of semisphere equals 1,072.33, what is it, miles cubed. So the volume of the semisphere is this, the volume of the prism is that. All we have to do, add these 2 numbers up, and we're finally done. I know it's ugly, but that's the way it is. So plus 3,015.93 equals. So our final answer after all of that work, total volume equals 4,088.26 miles, right? Cubed. So these kind of complex figures are going to be the hardest kinds of questions you see when it comes to volume. You will probably on your exam see 1 out of 60. I think there's 60 questions. 30 non-calculator, 30 calculator. It's close to 60. You will probably see 1 complex figure. But I wanted to show them to you just in case, because, you know, the very least, no matter what, you've seen it. All right. So we're done here. Now we have to talk about surface area because I put that on your test because we have to do it. But we're almost done. Surface area is decently fast. It's not. Oh my god, it's just going to be forever. Let's do this. Okay. So there are formulas for surface area. There are formulas. I, however, don't like them because you guys have enough formulas. They have thrown so many formulas at you, right? So I don't want to give you more formulas. I just don't want to, and I don't think you need to. And I'm going to show you how you can do surface area without even more formulas. But what is surface area, right? Well, surface area is, right? Let's do, surface area is, let's say the amount of, I want to define this, surface area, the amount of material needed, oh, this is another one. Why is it like this? All right, amount of material needed to cover the entire shape. Best explanation I can give for this is how much wrapping paper, like exact wrapping paper, would you need to cover this shape, this box in particular? That's what surface area is. So what I'm going to do is, yes, there's a formula for it, but I don't want to do that formula. I don't want to teach you a new formula. You got enough to memorize because your formula sheet for geometry is really, really, really bad. So you got to memorize the formulas anyways. So I'm going to show you how to break these apart and just do normal area. So looking at this guy, looking at this cube right here, you've got 6 rectangles. You got 6. You got the bottom and the top, left and right, front and back. Now all we have to do is break them apart and figure out which are which. So we've got a 5 by 6 one in the front, which means we also have a 5 by 6 one in the back. So this is 5 by 6, and this is 5 by 6. Because there's at least 2 of those, right? Then we also have on the left here, or on the right here, a 6 by 6, which means on the left we also have a 6 by 6. And then just to make sure, we got 5 by 6, 5 by 6. Oh, we got 5 by 6 in the front and the back, and we have 5 by 6 on the bottom and the top. So we have 4 5 by 6 squares, and then 2 6 by 6 squares. So this is also 5 by 6. And these are 6 by 6. Now I'll explain my reasoning here. So looking at this, if the bottom down here is 6, then across from it is also 6 feet, right? If this is 5, then across from it is 5. And if this is 6, above it is 6. If this is 5, then above it is 5. Right? And I can label this entire picture. If this is 6 and across from it is 6, across from 5 is 5. Right? It's getting complicated-ish, but pretty much everything has a label, right? This is 6 feet over here. This is 6 feet over here. And 6 feet back there. So, oof, that's ugly. Sorry, I didn't mean to complicate it. Essentially, what I'm saying is that using the information given to you in this picture, you can figure out all of these sides, all 6 sides measurements. And we have them all laid out here in 2D shapes. If we covered these 2D shapes, if we did their area formulas, right, then we're done. We add all those area formulas up, and that's our surface area. So if you did 5 times 6, that's 30. Well, this is 30, this is 30. Those are the areas of those boxes. And then 6 times 6 is 36, right? And then we just add them all together. So we have 1, 2, 3, 4 30s. So we could just do 30 times 4 plus 36 plus 36 equals. Surface area equals 192 feet, and this is where they're going to get you, squared. We are covering the shape. We're not filling it. Since we're covering it, your units are in units squared, not cubed. Surface area, area is squared, volume is cubed. Okay, so I know that's decently complicated, but I feel like it's much easier to not give you 7 new surface area formulas versus teaching you how to break shapes apart into 2D shapes and just finding their surface area, or finding their areas. So Let's move on to my next practice one, which was this guy because he's complicated. And he's only complicated because of one reason. Do they have right triangles? They don't have right triangles. I just have to draw it myself. So I'm going to start breaking this apart. You've got two right triangles. Forgive me if they're not perfect. All right. So you got two right triangles. You know, your bases, right? The guy facing us and the guy in the back. Then you've got the rectangle down here, the 13 by 6 rectangle down here. You've also got this rectangle right here in the back there. And then you have this diagonal rectangle. I don't know how to draw him. I'll draw him. I'll just draw him. Whatever. I feel like this one's much easier to see how we broke it apart because we've got everything like where it is in the picture. And then now let's put our numbers on here. We got a 13 by 10 triangle, right? And then same thing over here. And then this bottom rectangle is 13 by 6. Then this back rectangle is going to be 10 by what? Well, the distance from here to here is 6. So the distance from here to here is also 6. It's a rectangle, right? So opposite sides are equal. So this is 10 by 6. Now we get to the hard part, this diagonal guy. We know that this is 6 because it's labeled in the picture. The problem is we don't know the height or the length, whatever you want to call this side. We don't know it, which means we're going to have to find it. This side right here is also the hypotenuse of the right triangle, right? Yeah, that's fine. So following this right angle, it's an arrow that points to the hypotenuse. Looking at this right triangle, this guy's our hypotenuse. So unfortunately, we have to find that before we can find the surface area for this shape. And if you look up a formula for surface area of a prism, they even have surface area of a rectangle, or I'm sorry, surface area of a right triangle prism, which is what we're looking at here. You still have to find that measurement. So it doesn't save any time. But let's do it real quick, and we can find that measurement easily using Pythagorean theorem, which I hope you remember. It's a squared plus b squared equals c squared. A is either side, either leg, b is the other leg, and c is always the hypotenuse. So we're looking for the hypotenuse. We just got to plug in 10 and 13 into our formula here and figure it out. 10 squared plus 13, that is not 13, there we go, squared, equals, or will equal, c squared. So we can pump that into our calculator, right? We know 10 times 10 is 100, plus 13 squared equals 269. 269 equals c squared. Now the problem is how do we get rid of that squared? What is the opposite of the number squared? Well, you gotta square root. You square root both sides, and these cancel out. And all you do is the square root of 269 will equal c. So 269 square rooted is gonna be an ugly number, but it's going to be our side there. It's going to be 16.4. That's not that bad, actually. Equals C. Or, coming over here, 16.4 is that side. Now that we've got all our measurements, all we got to do is find our areas of all these shapes, and we're done. Area of a triangle is 1/2 base times height. So 10 times 13 divided by 2 is 65. So you know this is 65. You know this guy is 65 because they're the same. Moving on, our next thing is 13 by 6, and it is a rectangle, so it's 13 times 6. 13 times 6 is 78. Next one should be easy enough. 10 times 6 is going to give us 60. And our last one is 16.4 times 6. 16.4 times 6, 98.4. We're going to take all of these numbers, add them up, and that is our total surface area. So 98.4 plus 60 plus 78 plus 65 plus 65 equals. And our total surface area is 366.4 millimeters squared. Remember how we spent, goodness, 5-6 months on triangles? Anytime you get a 3D shape with a triangle as a base, there's going to be something like this. They're going to be like, hey, remember all that stuff about triangles? Apply it to this question. So Pythagorean theorem, sometimes trig, they're going to try and use that stuff to be like, I hope you remember this, otherwise you can't do this question. That's just how they work. All right, but we got through that. Let's keep going. I want to talk about cylinders because they're super weird. All right, so I want to talk about cylinders. I think I'll skip pyramid because I think you get the idea. So in terms of this pyramid, right, we would break it up into the 4 triangle faces. Right? And then the base, which is a rectangle. So all of the triangles have a height of 15, according to this line, right? And then like this one is 15 by 12. And on the other side of it would be 15 by 12. And then over here, you've got 15 by 15. And on the other side would be 15 by 15. And then your square here is 15 by 12. So I think we can skip the pyramid because it's pretty basic, right? It's following the exact same thing that we've done for the other shapes. The problem with cylinder, though, is the cylinder does not follow that. Cylinder doesn't follow that at all because a cylinder is weird. Let's go edit. There we go. And so a cylinder is weird because it actually breaks apart in an interesting way. It breaks apart into a rectangle with 2 circles. So if you imagine taking a Coke can, right? Imagine this was a can and you cut it. Like you cut the top off and the bottom off, and then you cut the can straight down the side in a perfect line. I can get a perfect line. I can do this. I line up all right. There you go. So you cut the can down in a perfect line. If you then took that and opened it up, like pulled it in this direction here, it would flatten out. And it would flatten out into a rectangle. So I'll show you, I'll show you real quick. If you take a cylinder and you break it apart, like you cut it down the middle, and you open it up, you're going to get this situation. So let's say you left the can top and bottom attached by 1 point or very small point, right? The cylinder would break apart into this figure because you could literally roll this up into the cylinder, right? Take this end and attach it to this end. And then these two circles would just cover, I'm trying to do this on the computer and I'm using my hands. Like you can see that, that's my bad. But then you would take this guy and bring him down, take this guy and bring him down, and they would cover the caps, and you would have your cylinder, you'd have your can back. So that's how this works. Now the problem, where did he go? There he is. The problem is that we don't know the rectangle's length. So like if I draw it out tiny, right? You've got the rectangle, then you've got the circle, and then the other circle. And there we go. So what do we know? Well, we know that the radius is 22. We got that guy. We also know that this guy right here is 124 because that's the height of our prism. That's the height of our rectangle. And we got to know this distance in order to find the rectangle. We can find the area of the circles. We already have the radius. So what is that distance? Well, that distance is also the distance around this circle. Literally, the distance around this circle. It's the circumference. If this circle flops down and covers this entire thing perfectly, like a cylinder would, then that's the circumference of the circle is the distance here. So we find circumference of the circle, we found our rectangle's length. So we got to do that. And circumference is 2 pi r. And we have all the information we need to do that. We've got 2, we've got pi, and we also have r, 22. So we're going to plug that in. 2 times pi times 22 equals. Coming back over here, that's 138.23. Well, 138.23 is the length of our rectangle over here. So let's solve this out. We've got our two circles with a radius of 22. I'll draw, so you've got circle 1, circle 2, our radii are both 22. And then you've got the rectangle, right? I'm not going to redo the numbers because we know the numbers, right? We're good. All right. Area of a circle is pi r squared. Trying to find places to put these. All right. Area of a circle is pi r squared, so we just have to do that formula, well, 2 times, right? They're the exact same circle. Top and bottom are the same. So we do pi times r, which is 22, squared, equals. So we know, I'm going to put them over here. Well, 1,520.53. That's bigger than I was hoping. It's bigger than my circle. All right, I'll put it in here. So that's 1,520. This is also 1,520.53 centimeters squared. We'll get to that. And then we got to do our rectangle, which is these numbers right here. 138.23 times 124 equals. So the middle section is going to be 17,140.52. And now we add them all up. So 17,140.52 plus 1520.53 plus 1520.53 equals total surface area 20,181.58 centimeters. All right. Almost done. 2 more examples and we're done. Sorry for the length of this video. I really am. But it is the last video of the class, right? So real quick, back to cylinders. You know, you gotta do the circumference to figure out this rectangle. Once you figure out this rectangle's length, you just do that times the height. There's your rectangle. Find the area of the 2 circles. Add all 3 together. You're done. Right? I know it's not the simplest, but I don't know. I think it's still better than memorizing a new formula. Except there are 2 formulas you have to memorize. Because cones break apart into a shape that we don't have the formula to. They don't make sense. It just, yeah. So cones break apart into, I'll do my best to draw it if you're at all curious. If you break apart a cone into a 3D shape, it looks like this. I'm sorry, into a 2D shape. It looks like this. And then there's the circle in the middle. And so this right here, this outer part gets wrapped around and it creates the point and it wraps around the circle. It's super weird. And since we obviously don't know, there's no formulas, there's no area formulas for those shapes you just saw other than the circle. We do our own. So surface area of a cone. It has its own formula. It's not difficult. It is going to be pi times, where is it? It's times r times L. You know, r, of course, is radius. L is the slant height. Slant height. What they mean by that is the distance from the point to the edge of the circle. From the point to the edge of the circle is the slant height. Not the height of the cone, not how tall the cone is, but the distance from the point to the edge of the circle. That's our slant height. But once you have it, well, it's really easy, right? We do pi times our radius, which is 18, times our slant height, in this case, 31. I'm going to plug that into our calculator and we're done with this one. Pi times 18 times 31 equals total surface area equals 1,753.01. What is it? Feet cubed. So, I mean, is it easier with a formula? Absolutely. Is it easier knowing 13 new formulas? Absolutely not. But cones do have their own surface area formula, and it is pi RL. Please, please, please commit this to memory. Please write this down. I'm going to send out, after I put out this video, and so I'm going to send you guys like a big formula list of all the formulas that are not on your exam, or at least aren't explicit, like they're not obvious. There's a lot. So that's why I try and keep the number of formulas down by not doing all the surface area formulas, because they really do they have a surface area formula for cubes, rectangular prisms, triangular prisms, square pyramids, rectangular pyramid. It's open cylinders. It's bad. It's much easier to just break them apart and do area. But when it comes to cones like this, and when it comes to spheres, let me edit. When it comes to spheres and cones, you just use a formula. Use the surface area formula. It's much easier because spheres, by the way, break apart like you've seen the stitching on a baseball. I'm going to do a terrible job of this because I always do a terrible job of this. But if you care, it breaks apart into a 2D shape that kind of looks like this. If any of you have seen the Wiggler episode from Adventure Time, he looks like that. All right. So it would break apart into these two shapes, and this part would wrap around this guy, and this guy would wrap around this guy, and so on and so forth. It looks like the stitching of a baseball, but these shapes do not have an area formula. So we can't break this apart into something that we can do. So we just learn its surface area formula. So surface area of a sphere is 4 times, oops, wrong one, 4 pi r squared. The reason why I don't like I really wish there was a better way to do this without teaching you the surface area formula, because this surface area formula looks so much like its volume formula. Volume of a sphere, 4 over 3 times pi r cubed. And then this is 4 pi r squared. They're so similar that I see students mix them up a lot, and I feel really, really bad. Because, you just put in the wrong formula. You did everything else right. You put in the wrong formula, got the question wrong. That's not fair, but it's the way it is. Now, in this question, of course, all we need is r. So 4 times pi. Our radius is 29 squared. Plug that into our calculator, and we're done. 4 times pi times 29 squared equals total surface area equals 10,568.32 yards squared. There we go. So you do have to commit this to memory as well. When I upload this to the quiz, I'll probably put these two formulas specifically there, or at least most of the formulas there, so you can just reference them without having to come through the video. But you do have to memorize these guys, so sorry about that. But we are done. I'm sorry for the length of the video. Just there's so much. There's just so much to go over, but we're done. This is it. This is the last thing I have to teach you in geometry. You finished, you made it. You got to take the test still, but I believe in you. So we've seen it all. We've done it all. Get this quiz done, and we'll take our test, do great, all that happy stuff. So talk to you later, and hope you're doing well. Peace out.